Hey everyone, welcome back to UPC Tech Hub. Today we're doing something exciting, a React and React Native intermediate level interview. Our guest today is a developer who's been working on real projects using both frameworks. Hi there, could you start by introducing yourself?
Hey, thanks for having me. I'm a React and React Native developer with around 6 years of experience. I've built multiple apps, from financial management tools to food delivery platforms, using modern stacks like React 19, Expo SDK 51, Redux Toolkit, and TypeScript.
That's great. Let's start with React architecture. How do you structure your projects when building scalable React apps?
I usually follow a feature-based folder structure: components, features, hooks, contexts, services, utils, folders. Each feature folder has its own slice of state, components, and services. I also use Context API or Redux Toolkit for global state, depending on the complexity. For large-scale apps, I prefer Redux Toolkit because it provides immutability, predictable state management, and built-in middlewares like Redux Thunk.
Nice. Could you give an example of how you used Redux Toolkit in one of your projects?
Sure. I'll take one of my recent projects, a money manager mobile app I built using React Native with Expo and TypeScript. In the early version, I used React Context to manage the state for income and expense tracking. It worked fine at first, but as the app grew with multiple screens, filters, charts, and analytics, the state became hard to manage. That's when I switched to Redux Toolkit for a more scalable architecture. Here's how I approached it. I created a separate transaction slice that handled all actions, like adding, deleting, or clearing transactions. Each transaction had properties like ID, amount, type, income or expense, category, and date. With Redux Toolkit, I didn't have to manually create action types or reducers. Everything came bundled through Create Slice. That made the code much cleaner and easier to maintain. For example, when the user added a new transaction, I simply dispatched an action like, and Redux Toolkit automatically updated the global state. Another major benefit was the integration with Redux DevTools. I could track every state change, which was a huge help during debugging. I also used Redux Persist to save user data locally, so even if the app was closed, all transactions remained stored and automatically synced with the backend once the user came back online.
Impressive. So how do you handle performance optimization in React apps?
Performance is crucial, especially in large apps. I usually apply several techniques. 1. Memoization, using React.memo and utilizes unacceptable to prevent unnecessary re-renders. 2. Code splitting, using React.lazy and suspense to load components on demand. 3. Virtualization, for lists with many items, I use libraries like React Window. For example, in one dashboard project, I optimized a 1,000-row table by wrapping it in fixed size list. This improved scroll performance drastically.
Great. Now, can you explain use memo and use callback with an example of when you used them?
In one analytics project, I used useMemo to cache filtered data that was expensive to compute, and usefulness helped me avoid recreating event handlers. These optimizations reduced unnecessary re-renders and improved rendering time by around 25% in the profiler.
Wow, that's a measurable improvement. Let's switch to React Native. Tell me about one of your real mobile projects and the technologies you used.
Sure. I recently developed a food ordering app using React Native Expo. It had tab navigation, SQLite local storage, and integrated REST APIs built with Express.js. The architecture was modular. Screens handled UI. Context plus reducers managed state, and services layer handled API calls. I also used React Navigation for navigation and Axios for HTTP requests.
Nice. How did you handle data persistence or offline capabilities in that app?
Used Expo SQLite to store cart and user data locally. For example, when a user added items to the cart, it stored locally, and when they came online, the data synced with the server. That way, the user never lost progress even without an internet connection.
Tell me about your approach to API integration and error handling.
In larger projects, it's a bad idea to call APIs directly from multiple components because it leads to repeated code, inconsistent error handling, and makes maintenance harder. So instead, I create a dedicated service layer, basically a single place where all the API logic lives. In that service, I initialize Axios like this. This means every API call automatically uses that base URL. No need to repeat it everywhere. Then I use Axios interceptors like this. Now this part is important. These interceptors act like middleware for every network request and response. So if the server returns an error, say 401 unauthorized or 500 internal server error, it passes through this interceptor. That allows me to handle all API errors globally. Maybe show a toast message like network error, or automatically redirect the user to the login page if their token expired. I can also log these errors for debugging, or even track them with monitoring tools later.
Many developers struggle to choose between Context API and Redux. When do you decide to use one over the other?
I use Context API when the app's state is simple and local, like theme or user authentication. But for large, complex apps with deep component trees, I go for Redux Toolkit, since it's better for scalability, debugging, and middleware support.
Excellent distinction. How do you make your components reusable and maintainable?
I focus on props-driven design and composition. For example, I build generic UI components like button, input, and card with flexible props. That allows me to reuse them across screens without duplicating code. Also, I rely on UI kits like React Native Paper and shadcn/UI for consistent design.
Finally, what are your top 3 best practices you follow when developing React or React Native apps?
My top 3 would be 1. Maintain clean folder structure and consistent naming conventions. 2. Use TypeScript to catch bugs early and ensure scalability. 3. Write modular, testable components, easier to debug and maintain. Also, I never forget to use ESLint and Prettier for clean code formatting.
Fantastic answers. It's great to see practical knowledge backed by experience. Thank you for joining us. And to our viewers, don't forget to like, share, and subscribe to UPC Tech Hub for more real developer interviews and tutorials.